Okay, so I found a mistake in in my last video. That's why it ended abruptly. But I was right here about to solve this inequality. So let me pick it up right there, solving this inequality. So let's start with that. And we are trying to find an interval containing one cycle. Okay, so we need to add pi over 2 to both sides. Okay, and then we are going to divide by by 3. So divide everything by 3. That would give us pi over 6 over here. And then over here we would have 2 pi over 3 plus pi over 6. 2 pi over 3 plus pi over 6. And so what this is telling me is that my graph, I can go ahead and draw a rough graph of this right now. With my beginning point would be pi over 6. My end point would be 2 pi over 3 plus pi over 6. And then in between there, I've got to fit one cycle of the sine function. So basically, I need to have something that looks like that. Okay. And so what remains to do, actually, a couple of more things I know about this. Since the amplitude is 2, I know that that is 2 and that is negative 2. What remains to be done is to find these key values here. And in order to do that, we find the length of each of these little intervals, okay? And to find that interval length, that's the period. I like to think of this as the increment. So the increment is that's my terminology, but it's the period divided by 4. Okay, so if the period, we already found the period to be 2 pi over 3, the increment is 2 pi over 3 divided by 4, which is, that's 2 pi over 12, and simplified, that is pi over 6. Okay, so what does that mean? That means that this length right here is pi over 6. It happens to have also started at pi over 6. Don't let that confuse you. That's just a particular thing in this problem. But for each one of these points, x sub 1, x sub 2, and so forth, x sub 1 is the beginning point, pi over 6. X sub 2 is pi over 6 plus the increment, which is pi over 6. X sub 3 is pi over 6 plus 2 of the increment, which is 2 times pi over 6. X sub 4 is pi over 6 plus 3 of the increment. And x sub 5 is pi over 6 plus 4 of the increment. And notice that this last point should also be the end. So they better be the same thing. So pi over 6 plus 4 pi over 6 is 5 pi over 6. Let's make sure that 2 pi over 3 plus pi over 6 is also 5 pi over 6. So let's just double check that, just so you believe me. So 2 pi over 3, 3 goes into 6 2 times. That's 4 pi over 6 plus pi over 6 is 5 pi over 6. Okay, good. So we ended up where we should end. And so basically, like x sub 2, that's pi over 6 plus pi over 6. That's pi over 3, simplified. And this is 3 pi over 6, so that's actually pi over 2. And this one is 4 pi over 6, which is 2 pi over 3, and then 5 pi over 6. So these values are actually pi over 6, pi over 3, pi over 2, 2 pi over 3, and 5 pi over 6. Okay, so that's the idea with finding the increment values and graphing the function with accuracy. Okay. Let's look at another problem. And I already did that. I just did this. So I should have scrolled down and did it on the chart, but I guess I won't do it twice. I just did it up here. Okay, I'll let y'all do that if you want to. Let's do a cosine problem. Determine the period, amplitude, and phase shift of -7 cosine pi x minus 4. Okay. So it's cosine, which I can't speak. Recall that the cosine graph looks like that, okay? So we're going to do some translation or transformation of this cosine graph. But anyway, I always start off by writing down what A, B, and C are. So A in this case is -7, B is pi, and C is -4. Okay, therefore, my period. Actually, I always do amplitude, period, and then phase shift. That's my preferred order for whatever reason. So the amplitude is the absolute value of -7, so that's +7. The period is 2 pi over the absolute value of b, which is pi. And so it actually simplifies to just be 2 because the pi's cancel. And then finally, the phase shift is -c, which is -4, and b is pi, -c over b. So negative of negative is positive, so that is 4 over pi. So we have the kind of a weird phase shift. By the way, I forgot to mention that the sign of the phase shift determines whether it's shifting left or right. It didn't really matter because we graphed it anyway, but like in the last problem, let me just go back to that for a second. We had a positive phase shift of pi over 6, and look how my graph turned out. It was the sine function moved over to the right by pi over 6, okay? So similarly, this is going to be a right translation by 4 over pi, okay? This problem doesn't actually ask me to graph it, but I'm going to go ahead and do that anyway, or at least roughly graph it. So let's figure out our start and stop. So to figure out your start and stop, you solve this inequality, adding 4 to both sides, then divide by pi, that's our start and stop, and then our increment is going to be the period divided by 4. So the period is 2, so 2 divided by 4 is 1/2. So our increment is 1/2. So, rough sketch, we're going to start at 4 over pi. That'll be my first point. My next point will be 4 over pi plus 1/2. My next point will be 4 over pi plus 2 times 1/2, which is actually just 1. And then my next point will be 4 over pi plus 1.5, which is 3/2. And then my next point would be 4 over pi plus 4/2, which is 2. And no surprise, our last point should be the same as the end point of the cycle, which it is, 2 plus 4 over pi. And so now I want to fit in my trig function. By the way, this one, since it has a, actually we have, I should have mentioned this, it's since the a value is negative, we also have a reflection over the x-axis. in addition to an amplitude of 7. So we're going to be going from positive 7 all the way down to negative 7. And we're going to flip this guy right here. We're going to be flipping it, so it's going to look like that. Okay. So this is going to be my first point down here. Then I'm going to be at 0. Then I'm going to be, my high point is right in the middle. And then back to 0, and then back down here. So that is going to look like that, more or less. A rough sketch of cosine, negative 7 cosine pi x minus 4. Okay, that's actually the last problem on this pre-class worksheet. So I have more to say. I'm going to pause the video here, and then in the next video we'll talk about some other related problems. Okay.